All right, in this video, I have another version of the CLTech drone, and this time I used carbon fiber. I went ahead and bought a CNC machine, and this is just using 2mm carbon fiber. And the way I designed this is I designed it so that it can be made just like I had it with the 3D printed one, where I could have just this main body right here, and then 3D print a bottom prop guard underneath. Or I can do it like this and add these prop guards on here. And the good thing about this is if one of these breaks, I can just replace this and put another one on, because you can see these are all separate. So I have 1, 2, 3, 4, 5, 6, 7, 8 pieces for the prop guards and just one piece for the body. So again, if anything breaks, I can just replace one piece. They're all the same, so I don't have to worry about replacing the whole body if something happens. So this is the 3.5 inch. I know you see a GPS. I don't have this hooked up. And the reason for that is I wanted to make this another indoor flyer. Notice I have the camera up front with a servo motor and some lights. So what can happen is if you're in total darkness, I do have a low light camera in here, but I can also flip a switch and the lights can come on. So if you're indoors and it's dark, you can go ahead and turn it on and still be able to fly. And the reason why I added the servo is from testing before with indoor drones, going up and down steps. And once I went into an elevator shaft, there's no way of looking up or down where you're going. So this at least gives me a good amount of tilt up and a good amount of tilt down for when I want to go up and down steps. So here's my 3.5 inch props. I'm using the Axis Flying 224, let's see, 3500 kV motors. I have a Speedy Bee on here. I had a Flywheel Goku, but that thing didn't have a motors port, an extra one, so that I could hook the servo up. I know that this one had one. Unfortunately, it's a stack as opposed to a single board, so that's why it comes out a lot farther than the other one did. But to combat that, I went ahead and just 3D printed this out of TPU to hold my VTX in here. That's a Rush FPV. So I'm getting about 1,000 watts out of this. This is a Max Solo, and I have, I believe, 800 watts out of my transmitter. So this should get me pretty good distance inside. So here's the connection for my GPS, but it's not connected. It's separated and just has some tape on it. If I wanted to go GPS and everything else, I'd have to reconfigure the whole thing. For me, let me know if there's something different, but there's no way of switching profiles to change all the settings that I need to be able to run GPS and also to be able to fly indoors and not use GPS and just use the camera and the LiDAR. But if you know of a way if you can do that, let me know. So another change for this, so you can see here I have a MFT-01. It's a LiDAR and optical flow. Before I had TF Mini Plus LiDAR, and I had a Maytech optical flow / LiDAR in the front. I wanted just to use the Maytech, but I couldn't because it didn't give you enough height for the Maytech, so I had to use those in combination. But with this one, it took me a while to configure it and figure it out, but I'm able to just use this one, and it seems to be working pretty good. I do have some fine-tuning to do when it comes to stabilization. It's a little shaky when it gets up a little higher, and I'll show you that when we fly. So that's pretty much it running around the drone. Going to be using my same transmitter. You can look at my other videos and see everything else that I'm using, but it's the same setup that I had before. Another difference is I'm using these 21700 45 amp batteries instead of the 18650s. Notice they're a lot bigger than the 18650s. They're not too big, and they go well with the 3.5 inch. I wouldn't use them on my 3 inch, but these are pretty good for the 3.5 inch. So I'll also time it and see how long of a flight I get with these. All right, let's go ahead and get in here.
Welcome to OpenTX.
And I'll show you while it's sitting here. If I hit this button right here, turns my lights on and off, and then this turns my gimbal up and down. All right, we're ready to go. And again, I'm using iNav. And I'll start off in angle mode. So right now I'm in angle mode. My second mode that I did on here, that I put on, was horizon. So I'll flick it. Not horizon, I'm sorry, that's altitude hold. And then the last one I did on here is position hold. So I'll leave it on altitude hold, and you can see this drifting, just maintaining altitude. So last one I'll do position hold and let off the sticks. See the wobbling I was talking about? And it's holding its position. So again, it took me a little while to get this working, but it's working now, so turn it around towards me. I'll turn the lights on. There's the lights, and I'll do another test at some other point, flying around indoors. Turn those back off. We'll just fly it around. So right now, I'm not adjusting. Well, I got to put my sticks in the middle. Try to find the middle spot to where the hover is. I'll bring it down low to where I want to get it. And now I want to maintain this height. So I'm going to go downhill. I'm not changing my throttle at all. And it's going down with the grade, because my property does go down. So I'll bring it back, and it's just start to climb a little. If not, it would have hit the ground. And it is climbing. And we'll just fly it around. Screen is nice and bright. It's too bright right now. Let's see what kind of, watch out. So again, I'll have to adjust that. And maybe one day I'll switch over to digital, but for now I'm just going to run it analog. See what it does with this hill. And it went up the hill by itself. I'm not sure what I got my VTX set for, but I am going through the house right now. Still able to see where I'm going. Let's bring it back down. Now I'm just going to fly it around and see how long this battery lasts. So here I'll stop and do the gimbal tilt. And then position hold. This is my gimbal tilt down. Gimbal tilt up. And we'll keep flying around. Go ahead and flip it to angle mode and then bring it in. "10 minutes and 47 seconds, not bad. All right, let me know what you think about this. I have to redesign this part here. I did have a crash when I was trying to figure out how to do this LiDAR, and it was just acting real crazy, and it shot up in the sky, and I almost lost it, and it crashed into some trees, and I got it back. And the camera, I don't know if you can see it, has some scuff marks in there. I think it cracked some of the glass up top, but it still works, so I'll keep using it. I'll probably go digital later. CLTech said they're working on a infrared / regular camera. Right now they have an infrared camera, they have low light cameras, but I asked them if they had a infrared camera slash low light, and they said they should have one pretty soon after they're done. And they did already make the infrared, so I think hopefully that's their next camera. That will be a game changer for this, and that would be great. I could blacken out the lights in here, or make a cover for this to blacken it out. And if you didn't have any light showing and it was using infrared, it could be a really good covert drone to fly in the dark. All right, that's it for the video, and we'll see you next time. Thanks for watching.